This is lesson 1, 2, 3. This is lesson 46. Warm up, solve each system by graphing. We can graph this top equation. Y-intercept is -2. Slope is down 1, right 3. Down 1, right 3. Sorry, down. Jeez. Slope is -2. 1, 2. 1, 2, 3. This is lesson 46 warm-up. Solve each system by graphing. We've got a y-intercept of -2 and a slope of -1/3. So that means down 1, right 3, down 1 and right 3, down 1 and right 3, up 1 and left 3, up 1 and left 3, and we've got our line. Our next equation, y-intercept is at 1, and our slope is up 2, right 3, up 2 and right 3, down 2 and left 3, down 2 and left 3, and we got our line. And we can see that these points, if I would have drawn my graph a little nicer, meet at -3, -1. Solve each system by substitution. Well, when we're solving for substitution, we're trying to solve one of the equations for one of its variables. So we can see in this top equation that if we solve this for x, it would just take us one step, and that's what we want to do, is be as efficient as we can. So x equals -3y plus 8, and the reason it's called substitution is we're going to substitute that value into the other equation. 2 times x minus 4y equals 6, and we're substituting in a -3y plus 8, so we distribute and we get -6y plus 16 minus 4y equals 6. Combine our like terms, we get -10y plus 16 equals 6. Subtract 16. -10y equals -10. Divide by -10. And we get y equals 1. If y is 1, we can substitute that into our other equation for y, -3 times y plus 8. And we're substituting in a 1, so x equals -3 plus 8, or x equals 5. That's the point 5, 1. Today we're going over, this isn't 7.3 anymore. We're just solving linear systems using combination elimination. This is lesson 46. Solving systems. And the question here is, what is the opposite of 5x? And then what happens when we add opposites together? So what is the opposite of 5x? The opposite of 5x would be -5x. And what happens when we add 5x and -5x together? We get 0. So if we can do that, we can do today's lesson. And that's what we're going to do, is we're going to combine equations to eliminate a variable. So that's why it's called combination/elimination. And our first example is our best one. When we're trying to combine equations to eliminate a variable, we need to make opposites. So that's our first step, is to make opposites. And we make opposites by multiplying. So to be opposites, we need to have a positive number and a negative number. So if I look at this, I've got a -3y and a positive 2y in both of these equations. Well, what's the smallest number that both -3 and 2 go into? Or just think of them as both being the same sign. So what's the smallest number that 3 goes into and 2 goes into? Well, they both go into 12. So what we're going to do is we're going to multiply our top equation by what times 3 makes 12 by 4. And so we're going to say 4 times x makes, 4 times 4x makes 16x. 4 times negative 3y makes negative 12y. And 4 times 11 makes 44. And so now what we're still trying to do is we're trying to make a negative 12 out of this 2y. So what could we multiply 2y, sorry, not a negative 12, the opposite of negative 12, which is a positive 12, times 2y. So what could we multiply that by? We could multiply that by positive 6. So 6 times 3x makes 18x. 6 times 2y makes positive 12y. And 6 times negative 13 makes negative 78. So now we made opposites. We've got a negative 12y and a positive 12y by multiplying by 4 and by 6. So now when we add our equations together, we get 16x and 18x, and those add up to make 34x. Our y's cancel out. So we get 34x equals, and now 78 minus, or 44 minus 78 is negative 34. When we divide by 34, we get x equals negative 1. So then we can plug this into either of our equations. It doesn't matter. Let's plug it into the bottom equation. 3x plus 2y equals negative 13, and we'll solve for y because x is negative 1. So negative 3 plus 2y equals negative 13. We'll add 3 to both sides, negative 13, and 3 makes negative 10. We'll divide by 2, and y equals negative 5. So that's solving systems by elimination combination. We multiply, our first step, multiply one or more of our equations by a number to create opposites. And here's our steps right here. So you guys try this and make sure you copy down the steps and use them. So our first step, rearrange the equations in like terms and columns. So we've got x's on top of x's, y's on top of y's, and constants on top of constants. That's done for us. Our next step, multiply one or both of the equations to create opposites. Well, I've got a 2y and a negative 2y, so that step's done for us too. Step 3, add the equations together and solve for the remaining variables. So we'll add these equations together and we get 4x, y's cancel out, equals 12. Divide by 4, and x equals 3. So step 4, substitute the value of the variable from step 3 into either of the original equations. So let's put this into this top equation, which is x plus 2y equals 5, and we're subbing in, put it into the top equation there. So we're subbing in a 3, so we subtract 3, and we get 2y equals 2, divide by 2, and y equals 1. So that's the point 3, 1. So you guys try this one. So take a second, hit pause, and try it. This one, use linear combinations to solve the system of linear equations. So we can see we've got, well, I've got a y and a negative y. So what is 1? This is a 1y. What is 1 and negative 3? What's the smallest number they both go into? Well, they both go into 3, right? So this one, I'm going to need to multiply this top equation by 3. And we'll say 3 times x makes 3x. 3 times y makes 3y. And 3 times 1 makes 3. And for this bottom equation, we don't need to do anything to it, so I'll just rewrite it over here. 2x minus 3y equals 12. And we'll add these two equations together. Our y's cancel out, and we say 5x equals 15. Divide by 5, and x equals 3. And then we can plug this into either one of the two equations. I'll plug it into the top one. X plus y equals 1. And we're substituting in a 3, so we subtract 3 from both sides. And we get y equals negative 2. So that's the point 3, negative 2. Try this one. Here we can see that we've got a y and a y. So I'm going to multiply this equation by a 2 and say that's going to give me 2x minus 2y. I just made the opposite of positive 2y. And 2 times negative 4 makes negative 8. This bottom one, we don't have to do anything because we already have the opposite. It's x plus 2y equals 5. And we can add our equations together and we get 3x equals negative 3 divided by 3. And x equals negative 1. We'll substitute this back into our our bottom equation. X plus 2y equals 5, and we're substituting in a negative 1. So we add 1 to both equations, and we get 2y equals 6. Divide by 2, and y equals 3. So our solution is negative 1, 3. And tonight's homework is homework number 46.